Homework 12.1, let's give it a shot. So in this one, we're going to start with an unknown number of firms n. We're going to use our free entry rules to figure out how many firms there are going to be. Then we're going to see what happens when we freeze it at that number and let two of them merge. Okay, so we've got n firms. N is presumably any number greater than 0. And each firm has a cost function, 400 plus 20q. And the total demand is given by 100 minus the price. So we're going to need to know the inverse demand. So we might as well do that right away. Easy. Find the quantity supplied by each firm in equilibrium and the total quantity supplied to the market. So this is a Cournot competition, and each firm I, is going to have the following profit function. Price is 100 minus Q, and then marginal cost is 20, and we multiply that by QI, and then we also have this fixed cost of 400, which we might as well put in to be technically correct, but it's not going to affect our choices. All right, capital Q, we can't work with that. We're going to need to divide it into two parts. The part our firm QI controls, and what everybody else does put together, which I'm going to call capital Q to the negative I. This is the total contribution from all other firms. Because that's all that really matters for determining the price. It doesn't matter if one of the firms does a lot and some of the other ones do a small amount. It's just the total amount of supply out there. Okay, so we'll replace that. Instead of Q, we're going to write QI minus capital Q negative I, which I don't have any control over, but does affect my answer. I'm going to take the derivative with respect to my variable of choice. And the derivative of this first term is minus 1, so we get a minus QI. The derivative of the second term is 1 minus QI minus capital Q negative I minus 20, and that's all equal to 0. The derivative of this is 0. We get our best response function. We add 2 QI to both sides, and that cancels out these two guys. And then we are going to end up with 100 minus capital Q negative I minus 20 is equal to 2 QI. So that's 80 minus capital Q to the negative I equals 2 QI. And we get our best response function, 80 minus capital Q to the negative I over 2. Next, we have to find in equilibrium, what's the Nash equilibrium going to be? So we're going to suppose via symmetry, which means all firms are the same, we're going to suppose that there's a solution where they all end up doing the same thing. So this is a notation that means QI is going to equal Q for all I, so everybody does the same thing. And that means we can plug some things in. We got to realize that this term here, if there are n firms, and capital Q to the negative I is the contribution of everybody else, there's n minus 1 other guys. Each one supplies lowercase q, so we can substitute this. We plug that in here, and we get Q equals 80 minus n minus 1 Q over 2. Solve for Q. Let's multiply both sides by 2. And then let's add n minus 1 times Q to both sides. And what we get here, 2 times Q plus n minus 1 times Q is equal to n plus 1 times Q. And that's equal to 80. And so running out of space here, but all we need to say is that 80 divided by n plus 1 is the Nash equilibrium amount supplied by each firm, and that means the total amount is n, since there's n of these guys, times 80 over n plus 1. Okay, so I get that by just multiplying this by n, because capital Q is equal to n times lowercase q, since that's how many firms there are. Notice I don't know what it is. It gets closer and closer to 80 the more firms there are, but the number of firms is unknown at this point. All right, using your answer to question 1, find the equilibrium prices and profit level of each firm. And this is still going to be a function of n. So we can plug these values right on in here. It's useful to solve p separately, I find. 100 minus q is equal to 100 minus n over n plus 1 times 80. Okay, and let's write the profit function for firm I is going to be this price, 100 minus n over n plus 1 times 80, minus our cost, which is going to be 20, and then my individual q is 80 over n plus 1. Okay? And we also have my 400 over here, my fixed costs. So I can simplify this a little bit. I get 80 minus n over n plus 1 times 80 over n plus 1. I can factor out my 80. So now it's 1 minus n over n plus 1 times 80 over n plus 1 minus 400. And n plus 1 over n plus 1, like, let's change this to this. If we subtract 1 from that, we get 80 times n plus 1 minus n is 1. So look at that. Everything is kind of looking pretty now. And so our profit is going to be equal to 80 over n plus 1 squared, if we put all this together, minus 400. Okay. This is the equilibrium prices and profits as a function of the number of firms. Next step, find out how many firms there are actually going to be. How many firms does this market support in equilibrium? So in equilibrium, we need it to be the case that if there are n firms in the market, each firm in the market is making a positive or at least non-negative profit. We also need it to be the case that if we had another firm enter, so if we went to n plus 1, this guy would make negative profit, so he wouldn't want to come in. And if life is convenient, we're going to find that right at this thing equal to 0, we get some whole number. If you don't, you just think like, usually it means that if you round down, that's the number of firms that satisfy this condition, and if you round up, you're in this position. So usually this is the way to start. To find n, you want to set your profit equal to 0. So let's see what we get. If we have 0 equal to 80 over n plus 1 squared minus 400, we can rewrite that as 40. 400 equals 80 over n plus 1 squared. Take the square root of both sides, and we get 20 equals 80 over n plus 1. Divide each side by 80, and we end up with 1/4 equals 1 over n plus 1, and that tells us n equals 3. So in this case, we got lucky that at exactly 3, profits are 0, which means if we had 4 firms, they would be making negative profits, so they won't want to come in, and this condition is satisfied. 3 firms in this market. So now that we know n, using your answer to 3, what's the equilibrium quantity supplied by each firm, and the entire sector, and what's the price? So remember, each firm was going to supply 80 over n plus 1. If n is equal to 3, we can see that this is 20. 80 divided by 3 plus 1, 80 divided by 4 is 20. Capital Q is equal to 3 times lowercase q, or 60. And the price is equal to 100 minus q, which is equal to 40. Okay? So those are our quantities. Now we're going to assume it's no longer possible for new firms to enter. Something happened, a regulatory change, whatever. We got stuck with these 3 firms. And now firms 1 and 2 decide that they can merge and lower their costs. Their costs go from 400 plus 20Q to 800, which is not good, plus 15Q. So they have higher fixed costs. Essentially, they double their fixed costs, but they have lower marginal costs. So there are some savings there, because remember it was 20Q before. If they merge, what's the new equilibrium quantity supplied by the merged firm and the other remaining firm? So this is another Cournot game, but it's a harder one because now the firms have different cost structures. We did this last week, but fortunately there's only 2 firms this week. So I'm going to call the merged firm firm 1, 2. To remind me, it used to be firms 1 and 2. Oops. The price is 100 minus the quantity supplied by firm 1, 2 and firm 3 minus their lower marginal cost of 15 times the quantity Q1, 2 minus their 800. So we take the derivative with respect to firm 1, 2's things, and you've seen this enough that you may have noticed the pattern. I'm just going to jump straight there. This is what the derivative of this first term is. The second term has a derivative equal to 0. Set that equal to 0. We now have 85 minus Q3 divided by 2 is equal to the best response. All right. So if you work through that step by step, you should be able to get to this state. For the other firm, everything is the same except we have higher costs. So their cost function, or their profit function, looks like this, except this is a 20. We actually already did these guys, and so we're going to end up with the same answer. 80 minus the supply of Q1, 2 divided by 2 is equal to Q3, best response. So the difference between these guys is this is an 85, which comes from the 100 minus 15, and this is an 80 coming from 100 minus 20. So this guy is going to supply less quantity in general than the other guy. He has higher costs. So we can no longer assume symmetry, so we're going to have to plug one of these into the other. So let's put that into there. So we have 85 minus 80 minus Q1, 2 divided by 2 all over 2 is equal to Q1, 2. So let's get rid of this denominator by multiplying both sides by 2. And now we have 85 minus 80 over 2. So that's 85 minus 40. Then we have a minus times a minus, so that's plus Q1, 2 over 2. And that's equal to 2 Q1, 2. This is 45. And if we subtract Q1, 2 over 2 from both sides, we end up with 3 halves Q1, 2. And then if we multiply each side by 2/3, we can get rid of that. And we find that in equilibrium, the new merged firm is going to supply 2/3 of 45, which is 30. And we plug 30 into here, and we get 80 minus 30 over 2. So this is 50 over 2. Q1 is equal, or Q3 is equal to 25. Remember, how does this compare to what we found in the original? Originally, they were all supplying 20. So the merged firms are supplying more, but actually so is the other firm. And this reflects the fact that there's more market power among each one, and each firm has got a bigger slice of the pie. Do I have to find the price here? Let's see. Just the quantity. So the total quantity is going to be 55. If we add that together. What's the new price? So the new price is 100 minus 55, which is equal to 45. So we'll call this P2. That's the new price. P1, the old price, was equal to 40. So the merger has caused the price to rise, which means it's bad for consumers. We could calculate their consumer surplus, but they have the same demand in the pre and post-merger worlds, but they have a higher price in the post-merger world, so they're going to have lower consumer surplus. In this case, there was a cost savings, but it was not enough to offset the increased monopoly power that let firms raise prices. So, what's the equilibrium profits of the newly merged firm? Does it increase their profits? Well, remember, when n equals 3, we found that profit was actually exactly equal to 0. So if he gets any positive profits, it's going to raise his profits. So the new profits, so the price is 55, and this guy's got marginal cost, so we should have this be firm 1 too, of 15, and we said he's selling 30 units minus a total cost or a fixed cost of 800, the higher one. So this is 40 times 30 minus 800. 40 times 30 is 1200. So minus 800 is 400. So he's doing better than pre-merger where they were just having 0. For the other firm, he's got a price also of 55 minus 20, higher marginal costs, and he's not selling as many units, 25, but he has a lower marginal or a fixed cost. So for this guy, we've got 35, times 25 minus 400, which is equal to 475. So actually, the third firm does even better than these two guys because even though he's got a higher marginal cost, he's got a lower fixed cost, and it turns out that that's important in this case. If this guy had a marginal cost of just 400 or even just a little bit less than 800, he would do better off. But anyway, you can see that it's in the interest of firm 3 to allow and support this merger to go through and not to wave any red flags and say that it's a big problem, because the price is going to rise and they're going to lose some of the market share. Like they're not going to get as much as the other firm, but they're doing better than they were when there were 3 equal firms. So being on the losing side of a 2-firm monopoly or 2-firm duopoly is better for this guy than being just one of 3 in a 3-firm oligopoly. That's it.